Okay. Well, I can show you the normal way to do these, and then I can give you kind of a shortcut.
Yeah, we kind of like we figured out a short because like she just gave us this worksheet at like the end of class and like showed us kind of how to do it.
Mm-hmm.
Like for degrees to radians, we just kind of plugged it in where you like move
Well,
the
here's the
decimal.
official way to do it. It's either, oops, excuse me, let me take a picture of this so I can write on it. It's either pi over 180 or it's 180 over pi,
Yeah.
depending on which way you're going. Now,
Hmm.
that's radians, right?
Hmm.
It doesn't say degrees, it's radians. So I want the radians to cancel, so I'm not going to use that one. I'm going to use 180 over pi because the pi is the radians, the 180 is degrees. The radians will cancel, and I'll be left with degrees.
Hmm.
If I'm going from degrees to radians, let's take this one. Well, then I'm going to multiply it by pi over 180 because I'm trying to lose the degrees. That
Hmm.
degree cancels with that degree, and you're left with pi over 3 radians. Okay? Now, you can use that technique on every problem on this page. But I'm going to show you something that I think is going to make it a whole lot easier. What's that equal to?
60 degrees.
What's that equal to?
Uh, 9.
45.
Oh, yeah, 45 because you go down.
And pi over 6 is equal to what?
30 degrees.
30. And pi over 2 is 90. Now, notice what all of these share in common. That times that is 180. That times that is 180. That times that is 180, and that times that is 180. And you should memorize these four anyway. You don't want to always have to be applying 180 over pi or pi over 180 to these simple ones. Okay, these ones where the only thing in the numerator is pi, not 2 pi or 3 pi, memorize these. It's really easy to memorize them. That denominator times the answer is always 180.
Yeah.
Okay, so let's go on. If pi over 3 is 60, what is 2 pi over 3?
120.
Piece of cake, right?
Yeah.
If pi over 4 is 45, what's 3 pi over 4?
135.
Notice how much quicker you can do these. If pi over 6 is 30, tell me what 5 pi over 6 is.
150.
This, to me, is the preferred method. Tell me what 4 pi over 3 is.
240.
There you go. Which one is quicker? Okay. Now,
Yeah.
let's go through all of the radians and do it that method.
So then that
Might need a calculator because you got to multiply 5 times 45. Although that's something you probably can do in your head.
yeah. 225.
Number 2.
Uh,
Now, this is a little different because 18 is in the denominator. Okay, so you can apply the regular conversion, or what's that got to be?
uh,
Remember, it's got to multiply to 180.
yeah,
So it's got to be 10.
yeah.
So,
Oh, and then 10 times
is
17.
that?
So then it's 170. Oh, wait. Couldn't you just multiply 180 times the numerator and then divide it by the denominator?
Sure, it's the same thing as what I'm doing by this simplified method. There's
Yeah,
no difference. You're going to get the same answer. Just a question of how quickly you get it.
yeah.
Um, but if you know these basic ones, and you knew that pi over 6 was 30, notice the 6 times the 30 is 180.
Hmm.
So I didn't know what pi over 18 was. I just knew that whatever it was had to multiply 18 and get 180. So it has to be 10. And all of a sudden that becomes an extremely easy problem.
Yeah,
If pi over 18 is 10, then 17 pi over 18 is 17 times 10, or 107. Okay? So you can use whatever method you want. If you prefer, let's do this the hard way. What's the conversion factor I'm going to multiply it by? Is it going to be
uh,
pi over 180 or 180 over pi?
180 over pi.
Now, notice the pi's cancel. That goes to that, and you get 170. But I'll bet you this took me a little bit longer.
Yeah,
Particularly on the ones that have the denominators 4, 6, or 3. Even 12 isn't hard to figure out what pi over 12 should be. So you've got your choice, okay? Just the only problem with this 180 over pi or pi over 180 is the chance of getting it upside down, which you really should never do.
yeah,
But if you do, it's going to mess things up. But more importantly, if you use that conversion factor, it's going to take longer than it would take the other way. So,
yeah.
that's 170, and I should put the degrees here, because that's really the only way to tell the difference between radians and degrees. I know that it looks like all radian measurements have a pi in them, but they don't. That can be a radian measurement right there. And you will get to a point in trig where you have radian measurements that are whole numbers like that. Not
Mhm.
everything is in terms of pi. So, basic rule is if it doesn't say degrees, it's in radians. Okay?
Yeah,
So doing it the easy method, what is that? As long as you know pi over 6 is 30.
yeah.
So what's number 3?
So then 11,
Pi
so
over 6
three,
is 30.
so 330.
Yeah. To me, that's just, I don't know. It's a couple steps easier and I can do it instantly. Now, let's finish doing all of the, well, at least the ones we can read on this page here. About 5 pi over 12. First of all, figure out what pi over 12 is. Remember, pi over 6 is 30. So what's pi
So then
over
with
12 have to be?
15.
Okay, now what's 5 times 15?
75.
What's number 10 say? Is that 5 pi over 3 or 2?
I think that says 3.
I think it's a 3 also. So what's this doing it the easy way?
Uh, is
Remember, your basis, your foundation of this is knowing those pi over 4, pi over 3, pi over 6.
yeah, so then that'd be 300.
Okay, good. Now, when we go from degrees to radians, you don't really have a simple method there. Tell me what the conversion factor is and tell me what the answer is.
Pi over 180. And then here, I need where? Okay, here, give me 1 second.
Okay.
So if it was pi over 180,
Times 60. The
yeah,
degrees cancel because there's a degree there. So the degrees, the units cancel. So you're going to end up with your answer in radians. And the only question is, what is 60 divided by 180? What does that simplify to? And cross the zeros off. Now the problem is, what is 6 divided by 18?
oh, so that pi over 3?
Yeah. And remember, we memorized that. We knew that pi over 3 was 60 degrees in the first place. So when you see 60 degrees, know that it's pi over 3. I really cannot stress strongly enough memorizing those 4 basic ones. Pi over 3, pi over 4, pi over 6, and pi over 2. Pi over 2 is 90. All right, now 190, oh, I suppose I could come up with a simple method. Not really. I
If you
can't think of any combination of 30, 45, or 60 that ends up being 190. So let's do it the hard way. What do I multiply it by?
pi over 180,
Okay.
so then 1 or 9, what is it? 19 pi over 18.
Yep. And I cannot simplify that. That is my answer.
Yeah.
About 300.
Uh, 30, 15 pi over 9.
Okay, that can be simplified.
Oh, so then 5 pi over 3.
Okay. Now notice that if I thought of that as being 5 60-degree angles, and I know 60 degrees is pi over 3, so that would have to be 5 pi over 3. So it
Yeah.
kind of depends on whether you can train your mind into thinking a certain way. And it works great on simple ones like 300. Doesn't work so well on 190. 190 is no combination of 30, 45, or 60, whereas 300 is. I don't want to put too much emphasis on that shortcut because you can always get by using the conversion factor.
Yeah.
Number 8.
And it'd be pi over 180, so then 135, and 13 pi over 18.
Yep. 13's prime, so that's going to be simplified.
Yeah. So 285. What could that be simplified to?
Well, first of all, we know it can be, because this is divisible by 5 and that's divisible by 5. So anytime you have a 5 and a 0, you know that they're divisible by 5, both of them. So do that for starters. Even if you have to use your calculator, do 285 divided by 5.
That's 57.
Now do 180 divided by 5.
36.
Now, can that be simplified? And don't forget to carry the pi forward.
Yeah.
First of all, what can that be divided by?
3.
Yes. So,
Then that'd be,
divide top and bottom by 3.
that's 19 pi over 12.
Perfect. Now, the fact that it took me 2 steps to do that, it means that both of these numbers could have been divided by 15, but I couldn't see that looking at them.
Yeah.
The only thing I was absolutely certain of is that they could both be divided by 5. And then once I got to this, notice that 57 adds, I don't know if you know this rule or not, but a number, if it's divisible by 3, then the digits have to add up to a number that is divisible by 3. 5 and 7 add to 12. That's divisible by 3. 3 and 6 add to 9. That's divisible by 3. So we know we can take it down another step.
Yeah.
Nothing special about negative signs. I mean, there actually is, but in terms of converting it to degrees, there aren't. Whatever the starting negative sign is, just continue it. What's pi over 3?
60.
What's 4 pi over 3?
30 or 240 or 24. I was like,
240. In other words, if pi over 3 is 60, well, it's 4 times 60. That's 240.
yeah.
So, and it's always got degrees, and you, whatever that sign is, you make that sign that. It's as simple as that. In other words, the negative sign has no consequences for these particular problems. Okay, now let's mix it up. Let's just go in the order. Let's do 350.
So then pi over 18. So then,
180.
or yeah, pi over 180. So then
Can cross out those zeros.
35 can be 30, 35.
Notice that 3 and 5 add to 8. So it's not divisible by 3. It's not divisible by 9. That's only divisible by 7 and 5. In other words, that is a second level prime number. The only factors of 35 are both prime. And that tells you that that's the only factors of it. Okay?
Yeah.
And 18 cannot be divided by either 7 or 5. So
Yeah.
I can't simplify it. Again, do not forget to bring the pi over. It's really easy to do that because you're so focused on these two numbers and simplifying them that sometimes you just forget to bring the pi over. Okay, how about this?
Number 13?
Yeah.
Oh, okay, so then 345 times pi over 180, and then 345 Uh,
What do those add to?
those add to 9, 12. So then divided by, and then that's 115 pi over, uh, 115 pi over 60.
Okay.
And then
Now we know they can both be divided by what?
5.
Okay.
So then that's 23 pi over 12.
Correct. 23 is prime.
Mm-hmm.
So that's almost certainly simplified. It
Yeah.
doesn't have to be just because 23 is prime. I mean, I can have this, and that's simplifiable into 1/2. But
Yeah.
if 23 is a bigger number than the denominator and it's prime, there's no way I can divide anything into 23, certainly not 12. The only thing is I could divide 23 into bigger numbers. Okay,
Mm-hmm.
14.
Okay, so 170 times pi over 180. And that's 17 pi over 180, and then that's it.
Okay, be careful here. It's 170 pi over 180, which is
Yeah.
17 pi over 18.
Yeah.
Okay, number 15.
Okay. So then,
Give me
so
the
then
conversion factor.
180 over pi.
Yeah, and because I noticed that, I realized, well, this is going to be so easy to do with the conversion factor, let's just use it instead of
Mm-hmm.
trying to figure out what pi over 18 is equal to and multiplying it by 11. Using the conversion factor is going to make this a piece of cake.
Yeah. So then that's just negative 110.
So sometimes the conversion factor is the way to go,
Yeah.
especially apparently if the denominator is 18
Mm-hmm.
and it's in radians, because you know your
Yeah.
conversion factor is 180 over pi, so that's going to work out real nicely.
Mm-hmm.
Let's see. Did I skip one here? I think no. 16.
Uh, wouldn't that just be pi over 18?
Uh-huh. Good. Okay, how you did it. You did it in one step. Okay, 17. Use the easy method.
Uh, so then that's 120, just because it's double above.
Yeah. In other words, as long as you know what pi over 3 is, this is definitely the easy method. One
Yeah.
thing about my method, my easy method, is you have to memorize those pi over 3, pi over 4, pi over 6.
Mm-hmm.
But you're going to memorize those whether you like it or not. They're eventually going to sink in by osmosis because you're going to get fed so many of them. Those are
Mm-hmm.
absolutely the three most important angles you're going to deal with are pi over 3, pi over 6, and pi over 4. That's 30,
Yeah.
45, and 60. Sound familiar from your special triangles?
Yeah.
Okay. So those are good to memorize. All right, how about number 18? What's pi over 9?
Pi over 9 is
Remember, the 9 has to multiply with your answer to equal 180.
so then it's 20.
Okay, so what's 11 pi over 9?
220, negative 220 is the answer.
Exactly. So certain denominators are easier to do than others. Uh,
Yeah.
9 actually is a pretty easy one to do because it's a nice round 20. And it's easy to multiply most any number that's going to be in the numerator by 20.
Yeah.
Okay, how about pi over 9?
So then isn't wait, That's just 20.
And 220.
And then 220 times pi over 180. And that's 22 pi over 18. And then divide that by 2 is 11 pi over 9. And that's it.
That's it, because 11 is prime and the denominator is smaller. So there's no way I can divide anything into both.
Yeah.
So, looks like you're in good shape on these. I can't see you missing any of these.
Yeah.
Now, the only thing is, as long as the instructions were not, don't give negative angles for any of your angles. In other words, what's the positive angle that's the coterminal to that? Have you learned coterminal?
Yeah, isn't that where you like subtract that by 3, or you do like 360?
You add 360.
Yeah. So
All you do.
then it's 140.
Okay, that's correct. Now, I'm not sure it's fair to say those are exactly the same, because 140 is this angle here, whereas minus 220 is that angle there.
Yeah.
It's just that the minus angles are measured clockwise, the positive angles are measured counterclockwise. They end up being on the same ray. And that is kind of the definition of coterminal. It's multiples of 360. In other words, I could have gone around twice and gotten to that. Well, that's going to be a 500-degree angle, this one here. So it's not that they're all three the same angle. It's that on the unit circle, they all end up being the same ray. And in fact, all 6 trig functions are the same for all 3 of these. So trig functions are exactly the same on any coterminal angle. If the sine of 30 degrees is 1/2, then the sine of 390 is 1/2, and the sine of 750 is 1/2, and so forth and so on.
Mm-hmm.
So, what else you got tonight, Blake? You got anything else?
That's like all my quizzes over tomorrow, and we didn't really have anything else to go over, so
Okay, that's fine. We can just do a half hour tonight.
yeah.
And I feel like you're pretty up to snuff on this stuff here.
Yeah, I feel like I'm definitely ready for my quiz tomorrow.
Yeah, I think so too. So, good luck, and I will talk to you next time, Blake.
Okay, thank you.
All right, bye-bye.